piecewise defined functions. So a piecewise function just has different rules for different values of the domain. So here, for instance, there we go. We have a piecewise function, c of x equals 39, and that's valid if x is between 0 and 2. Right? So if the value of x is between 0 and 2, including 0 and 2, the rule we're going to use is 39. If x is greater than 2, the rule we're going to use is 39 plus 15 times x minus 2. All right, so let's take a look at what that piecewise function is referring to. A cell phone plan costs $39 a month. All right, so that's, you're probably used to seeing that, where you have a fee for a plan, so long as you don't use more than a certain amount of data. So here, the plan includes 2 gigabytes of data. And so if you can use up to, can't use a negative obviously, you can use no data. Good for you, I've never managed that. And you can use up to, including 2 gigabytes of data, and you pay $39. But you're charged $15 per gigabyte for any additional data used. Right, so anything beyond the 2, that's why it says x minus 2, you're going to be charged $15 per gigabyte. I have a plan like that. I've been charged more than once $15 for using extra data. The monthly charges are a function of the number of gigabytes of data used. All right, so we want to find the value for if we use a half a gigabyte, 2 gigabytes, or 4 gigabytes. If we use half a gigabyte, right? Half a gigabyte is between 0 and 2, so we pay $39. You can write 30. We can write it as money, or we can just put 39. If we use 2 units, right? We're still within that 0 to 2, including 2. So we would still pay $39. But if we used 4 gigabytes of data, now we are no longer staying with where we were supposed to stay. We went over the 2 units, 2 gigabytes of data. So we're going to have to pay 39 plus 15 times 4 minus 2. All right, so that's going to give us 39 plus, that would be 15 times 2, or 30. Which is $69. Wow, that was pretty expensive, right? So this is an okay plan if you don't use a whole lot of data. If you use a lot of data, this is a lousy plan because you get charged an awful lot for excess data. I think I just get a $15 flat fee. For examples 2 and 3, we see that the value of a function can change from one input to another. The net change in the value of a function f as an input changes is given by, so this is just net change, right? So we have the value of one data point minus the data of another, minus the value of another data point, and we're looking at how much we changed, right? So let f of x equal x squared. Find the net change in the value of f between the given inputs. All right, so f of 1 would be 1 squared, or 1. F of 3 would be 3 squared, or 9. So the net change is f of 3 minus f of 1, which is 9 minus 1, or 8. So f of negative 2 is negative 2 squared, or 4. F of 2 is 2 squared, or 4. So here the net change is equal to f of 2 minus f of negative 2, which is 4 minus 4, or 0. All right. So there's no net change, right? This would be a horizontal line. It's whether you square negative 2 or positive 2, you get the same value. 1. So now we're going to be plugging in variables. They're not actually not variables. I guess they're a constant, but we don't know what the constant is. Right? So we have a, we have negative a, we have a plus h. Everywhere we see an x, we're going to plug in for that value. By the way, this one right here, we're going to see a lot next year in calculus. So, all right, let's find f of a. So f of a, we just plug in an a now wherever we see an x. So we have 2a squared plus 3a minus 1. That's not too hard, was it? Let's try b. Right, I should put an a next to it, I guess. Let's try b. So b is f of negative a. So that would be 2 times negative a squared plus 3 times negative a minus 1. We should simplify that. All right, so if we square a negative a, it's going to be positive. So this is going to be 2a squared. We're going to have now negative 3a minus 1. Let's plug in now an a plus h. So now we have f of a plus h. And so that would be 2 times a plus h squared plus 3 times a plus h minus 1. All right, so we'll square first. Remember the rule for squaring. This is going to be a squared plus 2ah plus h squared. We can distribute the 3. That would be 3a plus 3h minus 1. We can distribute the 2. 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. And then just combine the like terms. A squared and a, the other like terms. No, I guess there's no like terms. Never mind. There are no like terms. So we're done. Nope, not a single like term. All right, so now let's do D. All right, so D is f of a plus h minus f of a divided by h. So that's going to be 2a plus h squared plus 3a plus h. Oops, I forgot the parentheses there. There you go. Minus 1. And then we're subtracting f of a. And we already know what f of a is going to be, right? 2a squared plus 3a minus 1 all over h. And that h can't be 0, otherwise this would be undefined. Let me see if I can move this up just a little bit. Oh, that stayed nice together. Here, not so much. Probably because I paused. There we go. All right, so we know what 2a plus h squared plus 3a plus h is going to be because it's right there, right? And we are missing a minus sign there. I don't know what happened to it. All right, so we'll take care of the 2a plus h squared plus 3 times a plus h. That's going to be 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. And then we're going to distribute the negative there. So that's negative 2a squared minus 3a plus 1. All over h. I'm going to have to extend the page. There we go. Now let's combine our like terms. So we have a 2a squared and a negative 2a squared. So that's gone. We have a 3a and a negative 3a. So that's gone. We have a negative 1 and a positive 1. That's gone. All right, so we're left with 4ah plus 2h squared plus 3h all over h. And notice that we could factor out an h because every single one of our terms has an h in it. So that would be 4a plus 2h plus 3 all over h. We can cancel that out. And now we have 4a plus 2h plus 3. And right now, it's just an equation. It doesn't really have any meaning at all to you. But one day it will. But right now we're just practicing evaluating. Right? So we can evaluate anything in a function. We can evaluate we can evaluate finite values, or we can evaluate variables in a function. And I'm going to pause right here, and we'll come back to the weight of an astronaut in the next video. Thanks for watching.